Hi guys! This time we will be testing the hypothesis about a proportion. So let's have this one as an example. A manufacturer believes exactly 8% of its products contain at least one minor flaw. The business researcher randomly selects a sample of 200 products, inspects each item for flaws, and determines that 33 items have at least one minor flaw. Suppose a company researcher wants to test this belief. So what belief are we trying to test here? It is the belief that exactly 8% of its products have at least one minor flaw. And so let us use the H-tab method in solving or for testing the hypothesis. And our first step is letter H, establishing the hypothesis. Since we want to test the belief that there is exactly 8% of its products containing at least one minor flaw, our null hypothesis is that the mean is equal to 8% or 0.08. And our alternative hypothesis would challenge our null hypothesis. And now our alternative hypothesis states that the mean is not equal to 8% or 0.08. The next step is to actually conduct the test. And so we need to set our value, and as for this one, we set it to the value of 0.01, which corresponds to 99% confidence level, which has a z-score of 1.645 for a two-tailed test. We have also identified that the value of our p is 0.08, and our p hat is 33 over 200 or equal to 0.165. And so the p hat here is a proportion. That is why we get a proportion of the actual products, which is 33 out of 200. And our n is 200. So now let us compute for our z-score. The formula that we are using here is z is equal to p hat minus p all over the square root of p q over n. And so our p hat is 0.165. The value of our p is 0.08. This is divided by the square root of 0.08 and 1 minus 0.08, which is 0.92 all over 200. This ultimately gives us the final answer of 4.43. And so now let us take the statistical action by comparing our critical value and our observed value. Remember that our critical value at alpha is equal to 0.01 is positive 1.645, and the value that we have computed, or the observed value, is 4.43. Since 4.43 is greater than 1.645, it falls beyond and outside the non-rejection area. Thus, the null hypothesis is rejected.